Okay, let's start where we left off. We're talking about even and odd functions. So we're going to look at even and odd functions. If f of x is even for all x in the domain, then we have f of negative x equals f of x. If f of x is odd, then f of x equals negative f of x. So we said even is going to be symmetric. With respect to the y-axis. So that means even. Now what does it mean with respect to the y-axis? Well, we're saying that if I have a point over here, then there's going to be another point on the other side right there. If I have this point down here, then there's going to be another point over here. Or if I have this point, then there's going to be another point over here. So if I were to fold it on the y-axis, you would have this piece laying right on top of this piece then, right? So we can look at a function. If it looks like it's even, then we know this, if it looks like it's symmetric with respect to the y-axis, then we know it's an even function. Now, the next one for the odd function, its graph, is going to look something like this. Okay, so this one is not respect to the y-axis, because if this is to the y-axis, then this point right here doesn't have anything to reflect to on this side. So we know that that can't be even. So if it's odd, then this f of x over here is equal to the opposite. So down here would be the opposite of what this one is, right? So this one is symmetric. With respect to the origin. So that means if it's respect to the origin, we know that it's odd. This would be f of x, and this would be negative f of negative x. But respect to the origin, what does that mean? That means if I have a dot here, instead of going across the y-axis, I'm going to go through the origin, and there's going to be another dot on the other side that matches it. If I have this dot right here, I'm going to go through the origin, and I'm going to have another dot over here that it matches. So that's what we call with respect to the origin. So one going through the origin to the other one would give you another dot. So now we're going to decide how do we determine, looking at an equation, not the graph, which way is it even or odd. So even with respect to the y-axis and odd with respect to the origin. Now, you might also see with respect as WRT. So if you see WRT on something, that means with respect to. See how we said with respect to? All right, so let's try an example. So determine even, odd, or neither. So even, odd, or neither. So we have f of x equals x cubed plus x. So first thing we have to do is find out what f of negative x is, because that's how it's comparing it, right? So f of negative x would be inputting negative x in for x. So every place there's an x, we're going to stick negative x cubed plus negative x. So negative times negative for cubing is going to give us negative x cubed, plus a negative is going to give us minus x. Now we have to compare this answer with this answer. So see how both these have a negative? We can distribute out. Obviously we can distribute out an x too, but we want it to still look like this one. This is going to give me x cubed plus x. So what is this? This and this are opposites of each other, right? So we're saying f of x f of negative x is equal to the opposite of f of x. See, there's the opposite right there of this one. So even, odd, or neither. If f of x is equal to the opposite of f of negative x, then we're going to say it's odd, right? Just think in the words of the word like saying the opposite of it and see what that does. All right, so we're going to try another one. We're going to try g of x. So we want to find g of negative x first. It's got 1 minus negative x to the fourth, because we plugged in input into there for negative x. Negative times negative times negative times negative, an even number of negative signs is going to make that positive, right? So 1 minus x to the fourth. So are they opposites of each other this time, or are they the same? 1 minus x to the fourth, 1 minus x to the fourth. So g of x is equal to negative g of x, which would make it even then, right? If they're opposites, it's odd. If they're equal to each other, it's even. Now, we said even, odd, or neither, so obviously we need to try a neither one. So we have h of x equals to 2x minus x squared. So how do I know that that's going to be neither? Well, we plug in h of negative x again. 2 times negative x, because we're putting negative in for x, minus negative x squared. Negative times positive gives me a negative 2x. Negative squared gives me a positive x squared minus, so minus positive x squared. So is this and this opposites, or the same, or neither? Well, if I take a negative sign out of this one, that's going to give me 2x plus x squared. So is this the same as this? No, because we have a minus sign and this one has a plus sign. So this is another example then, and this would be a neither. So if they're the same, it's even. If they're different, then it's odd. If they have a little bit of both of them, then it's neither. Okay, so that's section 2.6. Thank you.